Hello, this is how to create a good stack trace if a Flatpak application from Flathub crashes. Let's take everything from scratch. We have Flatpak already installed. This is the Linux operating system Ubuntu 25.04. There's no Flatpak remote. Let's install a Flatpak. We're going to use the KDE application kcalc. On flathub.org/labs/org.kd.kcalc, let's make sure that we have the Flatpak remote FlatHub available. The command line is this one. Additionally, most of the Flatpak commands, I'm going to run them per user, not per the entire installation. So I'm going to add the command line parameter user. Let's list the remotes. So now we have the remote named FlatHub from this URL, and it's not installed per the entire computer, but just for my user, per user. Next up, we want to install the application kcalc. This is the command line. Again, we need to go per user. Okay, this is a Flatpak package, has dependencies, depends on OrgKD platform, depends on Org Free Desktop platform, and then there's various additionals such as OpenGL, graphical user interface acceleration, theming for GTK3 apps, and the translations for kcalc. So this kcalc.local package. Everything comes from FlatHub, so that means these are stable Flatpak packages, not built from the Git master branch of the KDE Git repositories. I agree. Now we want to see if the installation was correct. So that's Flatpak, run, and then there should be auto-completion. I just press the O key and then the tab key. Everything was auto-completed, so this part rg.kd.kcalc was auto-completed. This is because I'm using Bash and Flatpak has support for auto-completion in Bash. Okay, so the application starts. Let's see if it actually works correctly. Where is the square root of 1, 2, 3, 21? Should be a round number, 111. Okay, so it does work. Okay. Let's now pretend that this application crashes, and let's collect a correct stack trace, which then can be used when creating a support ticket. So let's start the application and let's try to crash it by sending it a message. I searched on the internet and people say that we should send the Linux signal SIG-SEG, so that's signal segmentation violation, to the process ID of the kcalc process. So we do that by listing all of the processes. There's an entire process tree, which is for kcalc being run inside the Flatpak container, inside the Flatpak instance. We're interested in this one. So this is the process ID. And the command line would be like this, kill space minus SIG-SEG, and then the process ID. Not the grep, this one. Okay, the graphical user interface process disappears. Probably its parent processes clean up correctly, the bwraps, the Flatpak instance in general, but still nothing is shown to the user. There's no graphical user interface message box saying that, hey, this application has crashed and you should report this and where you should report this. So the application just vanishes. And also if you run the application from the command line, but then almost never people run Flatpak applications from the command line. Almost always, because Flatpak applications are graphical user interface applications, you start them from the start menu of your desktop environment. In my case, it's KDE Plasma. So you don't even see the standard output and standard error from Flatpak. But still, even so, it doesn't say that the kcalc process has crashed, has encountered this signal segmentation violation, nothing. So on Google, I searched for Flatpak how to generate backtrace. Takes me to the official documentation from Flatpak. Most of the information relevant to what we're after is concentrated on this extremely short page. And let's see what it says. So it says that when you build Flatpak packages using Flatpak Builder or Flatpak Build, often you are going to create multiple Flatpak packages for your application. In our case, for the application kcalc, an additional Flatpak package is generated automatically, which is the one for localizations. And there's also another one, which is org.kd.kcalc.debug, which contains the stripped debug symbols. So probably kcalc by default is being built using cmake build configuration rel with debinfo, which means make the executable fast and optimized, but then make it also contain the debug symbols. And then those debug symbols are stripped out of ELF files, out of SO files, out of executables, and copied into their own Flatpak. Again, with the same name as the main package, but ending in .debug with an uppercase D. So what we're after, we want to install the debug Flatpak package for org.kd.kcalc, for org.kd.platform. We want to install all of the possible SDKs. So whenever you see platform in the name of a Flatpak, you would also want to install the equivalent SDK. So if you have org.kd.platform installed and it's required by kcalc, then you should also install org.kd.sdk with an uppercase S. Let's actually list. As you saw, I had Flatpak installed, but no Flatpaks, no Flatpak packages were installed. I didn't even have a Flatpak remote configured. This tells me that all of the Flatpak packages that I have installed, all of the output from Flatpak space list command line is actually needed, required by the application org.kd.kcalc. So I'm going to install as many other Flatpak packages as possible which are related to these packages. Okay, so let's see. It asks us to include SDK and include debug. This will actually install some Flatpak packages. And then Flatpak ID is going to be the ID of our application, which is org.kd.kcalc. So we need a command line like this. Okay, and we want to always install Flatpaks just per my user. So never, Flatpak install should never require sudo password in my case. And we can already see that For the org.kd.platform, it's going to install the equivalent org.sdkd.sdk with the same CPU architecture, x86-64, and the same version, 68. You can see it in here. So do you want to install? Yes. It's going to also install additional debug packages, one for org.kd.sdk, one for org.kd.kcalc, something for org.freedesktop.sdk, and we're still missing debug packages. Installing Flatpak packages has finished, so this command line has finished successfully. Now let's list the installed Flatpak packages. Using Flatpak list, you can get the help -- help. In here it says that there's this parameter -- all, which will list all packages, whatever, all Flatpaks, including locale and debug, and we can see a large difference in the listing. The first list, Flatpak list, doesn't say anything about the .locale Flatpak packages, and doesn't say anything about about some of the .debug packages. Does say something about these i386 debug symbols for the org free desktop SDK. Okay, because we're using a KDE application, the platform of the application org.kcalc is not org.freedesktop.platform, but instead it's org.kd.platform, this guy. And in here it says that once I have installed the debug package for the application, for the platform, once I have installed the SDK, the debug package for the SDK, it's a good idea to also install the debug packages for the GL packages. For that, we're going to look at this column branch, and we want to install these, for these two branches, for these two packages, their debug package. Let me zoom back. Okay, so let's see how that works. We want to install something like this. So we don't have GL32 installed, means probably that org.kd.kcalc is a AMD 64-bit only application. We want org.freedesktop.platform.gl.debug.default. Wow, so the debug is before .default. The branch is correct, is 24.08, this guy. And we want to install per user. Yes. And then we'll see if it's possible to also do it for the branch 24.08 extra. So that was successful. Just the branch changes has 5 extra characters at the end. Okay, so do notice that .debug is not always the last part of the reverse DNS notation name of the Flatpak package. Sometimes there's also this .default possibility. Okay, let's look at the Flatpak list all again. So there's this package with its debug, this package with its debug. I don't really care about H.264 video decoder, so I'm not going to install the debug packages for this thing. I also don't care about the breeze theming. I'm not sure if the platform does have a debug package, this guy, org.kd.platform. I'm going to guess that just the SDK has a debug, but we can test easily. So that's Flatpak install org.kd platform debug, and the version is 6.8. Okay, so for this line, org.kd.platform, we want .debug if available, and then the branch is 6.8. And there's no such thing. So all of the stripped debug symbols have been removed from are not part of the org.kd.platform package, but are part of org.kd.sdk.debug package. So now we should be full. We have all of the debug symbols possible. At this point, we will need to enter the Flatpak instance of kcalc. So let's see how that works. sh is the shell. There's a slash whatever, similar to s/usr/bin/sh. Default shell in there, which is actually bash inside the Flatpak instance. So a Flatpak instance is similar to a Docker container instance, to a Linux container instance. You're inside a very special chroot-like environment where you see a different file system structure, different directories under /usr. The application itself resides under /app. But you can put inside that container instance all sorts of goodies, like you can put your home directory, probably with -- file system home. You can give it additional permissions than the ones specified in the manifest of the application. For instance, you can give it unrestricted access to the network. And for instance, you can give it access to the current directory, in my case, ~kd/src, but I don't really need this thing. Okay, let's see how far we get. Only when we do Flatpak install, we need to specify --user. Flatpak run will run whatever is available and already installed. And I have Flatpaks installed only per user. So no need to go Flatpak run --user. Okay, and then Flatpak ID, which is the ID of the Flatpak package that we're talking about, which is kcalc from FlatHub. Okay, and we're inside the running instance of Flatpak environment. In there we have the possibility of GDB, which we're going to actually use. So GDB /app/bin, there's autocompletion. Kcalc is the name of the executable, takes no arguments. Then what we probably want is run and beautiful. No debug info D, so the default option is okay, no. And we want to wait until the graphical user interface application runs correctly. There's no breakpoints. GDB will just monitor the process. Kcalc will not actually stop anywhere. There's no breakpoints. Okay, let's see if we have actually attached to the correct process. Isn't there any bubble wrap parent of this process? How do we see that? Indeed, there's no bubble wrap. So we're inside a very special Flatpak instance, so similar to a Linux container instance. That's of type --debug. This is what the documentation from this page says, that we want to use --devel command line parameter, which we did, which will also put inside the instance the SDKs, the debug symbols, various debugging tools which are part of the SDKs. So there should be GDB, maybe Valgrind, maybe strace. So additional debugging tools, debug symbols. The sandbox will now allow debugging. The sandbox doesn't really seem to exist, or maybe it's just a very thin layer around the sandbox, because I don't see those BRAP processes. Which we saw previously. But they're still there. But the BRAP processes are around SH, because this is the entry point that we provided. Okay, interesting. It's better if GDB attaches to the process directly, does not attach to an entire tree of processes, and kcalc is just the final child of that process tree, because I'm not exactly sure even how GDB will get to the kcalc process if there's a number of intermediate processes between GDB and kcalc. You should probably tell GDB to follow forks or children or something. Like we can see now, it looks great. And if the application has started, we should do what we did before, which is crash the application. So let's see. PS AUX grep calc. We're not inside the Flatpak instance. We're on the host computer, but still all of the processes that run inside the Flatpak container instance are visible from the host operating system with the correct process IDs, and we can send them kernel from the kernel mode Linux signals. So we're after this guy /app/bin/kcalc. This is the process ID. And the process did not stop yet, because the kcalc process is wrapped by the GDB process. The GDB process has seen that the kcalc process has crashed with sig-seg segmentation violation signal. GDB is a debugger, has paused kcalc such that it can do things on the kcalc process before the kcalc process actually disappears. Okay. And we have a very short call stack from thread number 1, which is probably the main graphical user interface thread, but we're going to see immediately if that's the case or not. And importantly, the call stack already looks correctly. There's nothing that's not available. We can see the line number, we can see the C programming language source code file, We can see function names. We can see lists of parameters. We can see values of parameters. This sigmask is 0, so null. The timeout is null, etc. Okay, we're at this point, and now we probably want to run BT full. This is what we're after, a complete good stack trace without any question marks, without any missing symbols, without any missing file names, missing line numbers. So everything's available here. So actually the main graphical user interface thread is the thread number 0. And this is not the thread where GDB has seen 6f being received. It has seen it on in here. No, not in here. Thread 1. Okay, so thread 1 is human readable version of thread 0, which is the programmer version. Okay, so let's see GI people. The same thing in here. The same file number, file name and line number. We can see that the executable kcalc was built using CMake build configuration rail with deb.info. Many things are optimized out, which is not perfect for debugging purposes, but should be more than enough for reporting support tickets. Okay, so this is it. The call stack is great. What we want to do now is to actually get the call stack printed into a text file. And we can do that in multiple ways. We could go C for continue without paging. And then somehow, if the entire call stack is in our graphical user interface terminal, then we can copy paste everything that's inside the terminal. Do note that the terminal, the graphical user interface application, has a buffer, which is not limitless. So maybe not the entire full call stack is inside the current buffer. You could increase, for instance, the buffer of the graphical user interface terminal application in that case. Let's see how that works. So edit, select all, edit, copy. Let's put this thing into a text editor and remove the parts that are not part of the call stack. We can look inside the minimap to see where. So the call stack starts here where it says BT full and ends at the very end. So just copy pasting from here from BT full is enough, but you might also want to send as a part of the bug report all of the steps that you took. Like in this case, we can see that we're using GDB to run /up/bin/kcal, so that might be useful. We also can see that we entered a --devel Flatpak instance with the bash as the entry point. We could also see that we've installed additional packages. So maybe you want to include all of this information inside the ticket where you're reporting the issue. So probably from here until the very end. Okay, so this is a complete correct stack trace. Again, you can see the names and types of all parameters. You can see the names of methods, static methods, free functions, etc. You can see D pointers. You can see a ton of C++ template types, values of pointers, everything that can be visible inside a stack trace is visible here. There's this caveat that a bit of the information has been optimized out by I don't know, probably G++ minus O2 compiler when it optimized the executables. But if somebody requires that you provide a stack trace without anything optimized out, and that's a different thing. You will need to build kcalc as a Flatpak, but not with rel with debinfo CMake build configuration, but with debug CMake build configuration. That's going to be a very advanced topic, and probably nobody is going to ask, no developer will ask such a thing from a user that reports an issue. Okay, there's different ways to get at to copy paste the stack trace. Another way to do it is to tell GDB to write to a text file. I searched on Google GDB how to log commands. We want whatever we see in the GDB interface. So this is the GDB REPL. In here we have prompts, commands, and output from those commands. Everything we want it to be written automatically by GDB into a text file. So how we do that? First of all, we look at the current configurations inside GDB. So that's show logging. Says that logging is not enabled in the sense that logging is not whatever is written at the REPL is not written to a text file. So let's do that. Set logging enabled on. Automatically will write to a file gdb.txt, but we don't really know where these things being written. At this point, we should probably have given access to the current directory as it's specified in here. So --file system equals $pwd. Let's do that and be back. Let's see how we actually do this. So GDB Control D, quit anyway Y. We're inside the Flatpak instance, Control D. And now we should provide this command line parameter. So after the val. Okay. And back. Let's run GDB. Let's see, there's no history here, unfortunately. So we want GDB and the full path to the application app bin kcalc. It's going to start. We go run. Asks if we want debugging for D. No. It's going to take a while to start. And then the commands that we want are set logging enabled. Set logging enabled on. But we're not stopped, so the debugger is not yet stopped. Let's crash the application. We want this one, so like this. Okay, now GDB is paused. We're inside the REPL, read the evaluate print loop. We're seeing the prompt is GDB between parentheses and then a space. And in here we can enter commands. So set logging enabled on. It's going to create a file gdb.txt. That's okay if we know where that file gets generated. Set logging file will change the name of the file that's being written to. So currently probably writes in the current directory in gdb.txt file. And if you want something different, then this is the way you do it. Set logging space file and then the full path of the file. And probably if this thing works, -- file system equals home, you could just write to your home directory. So go slash your username slash home slash your username slash a.txt, for instance. Logging override should be on. And that's it. Okay. We're now ready to continue. We did run GDB command while SIG-SAG is being caught by GDB. So this is what we want. BT full. C without paging. And let's see if the information is there. So Control D to exit, Y, and here it is inside the host computer. gdb.txt, and only shows the output of the command that we provided. Yeah, this should be enough for our needs. So the full path, the output of BT space full is available in a plain text file inside the host machine. So always when working with this technology, Flatpak, do remember that there are two different worlds. There's the host operating system, and then there's very ephemeral Flatpak instances. So instances are similar to Linux container instances. When you start a Flatpak instance, you need to specify what you want mounted and available inside that instance by specifying the Flatpak ID. So org.k.kcalc will be a different file system available if you go Flatpak run and then in org.kd.kcalc versus Flatpak run org.kd.kate, for instance. Totally different file systems available in these two Flatpak instances where you're running in one kcalc and in the other the kd text editor kate. And then using the value specify that. So by default, if you don't specify --devel org.redesktop.platform or org.kd.platform, wherever your platform is going to be available in the file system inside the Flatpak instance. But if you go --devel, also additional things will be available in the file system inside the Flatpak instance. You will have debug symbols. You will have the SDK of the platform. There's additional debugging and building tools. And then you could go even extra, have even more things inside the file system, inside the Flatpak instance. So you can have file system and then any directory. Probably you can specify the entire home directory. And there's additional file system, the additional directories that you can make available inside the Flatpak instance, and also additional Flatpak packages or additional extensions, for instance. Okay, so that was it. That was, I have a Flatpak application installed from FlatHub. It crashes. I want to report a issue. I want to create a ticket inside the issue tracker for FlatHub or for that Flatpak or for the upstream of that Flatpak application. And the developers from there, which are working on the support ticket, are going to ask, hey, please provide a full correct stack trace. And this is the way you create it.